Hello everyone and welcome to this video. My name is Marjolein Kleijer and I'm application engineer at Antennex. And today I would like to show you how to measure the antenna efficiency of a passive antenna using the wireless connector. The wireless connector is based on a reverberation chamber, and for antenna efficiency we use it in combination with a vector network analyzer. Today I have a streamlined VNA of key sites which is being controlled by my laptop to do this measurement. And what I have is a passive Vivaldi antenna. It's operating from 5 to 40 gigahertz and it has a 2.92 mil interface. And I would like to know what the antenna efficiency of this one is. Before we can do a measurement, I first need to make sure that I only measure the efficiency of the antenna and not also including the cables that are connecting my antenna to the VNA. So I'll quickly show you the inside of the chamber. So inside the chamber, I've prepared a 2.92 female cable, which is through the side of the chamber connected to the VNA itself. And what I would like to do is that the reference plane of my VNA is at this point of the cable to make sure that I only measure the antenna efficiency of my antenna itself. So we'll first quickly start by doing this calibration, and you can do this just simply on the VNA itself and just use the VNA software to make sure that that reference plane is moved to the end of the cable. I will do that by a simple short open load calibration using 3 calibration standards. Okay, so now I've performed a calibration of the VNA itself and my reference plane is at the end of this cable. So now I can connect my antenna to it. Now I'm ready to start a measurement. And for this, I go to the wireless connector where we have multiple applications where I select the efficiency application. Since I'm doing a passive antenna, I'm going to choose for the reciprocal way where I just use a one-port measurement. I make sure that I've selected the correct port. At the moment, I'm connected to port 1 of the VNA, so I will select port 1. You need to make sure that your VNA is, of course, connected to the chamber itself. For this, we have a simple Ethernet cable going from the chamber to the VNA. Actually, in this case, my laptop, because my laptop is controlling the VNA. And for that, we set the IP address of the Ethernet connection of my laptop inside this chamber, which you can do in the system settings. As soon as you've connected, you can set the IP address, and the chamber will let you know that it is set up and that the device is being connected, and you can even see if the correct VNA is connected to it, because it will load which type of VNA it is detecting. Then we can set up the measurement. And for the measurement, we can set up the amount of stir positions. That is the amount of averaging you're going to do in the reverberation chamber. The more positions we take, the more accurate your measurement will become, but of course the slower your measurement is, because it will be taking more time to take more positions. For this demo, I will choose to use 50 positions. It's quite a quick measurement, but accurate enough for me at the moment. And then we have to set up the acquisition settings. The acquisition settings are post-processing settings, the acquisition settings itself, and also the frequency. For this measurement, I'm going to use a frequency band of 20 to 22 gigahertz, I will use the default acquisition and post-processing settings. So now I'm already ready to go, and I only have to press the button measure. The VNA is now currently capturing the S11 data for multiple stir positions, and in the end, the chamber will take care of all the processing. So the chamber is now communicating with my laptop, so the VNA. It's capturing a measurement for each position of the stirrers, and in the end, it will do the averaging and post-processing on the chamber itself and show you the end result. We have to wait for a little bit. but it just takes a couple of seconds in this case for 2 gigahertz of bandwidth. So the measurement is actually already done. It's now post-processed the data and we can see the end result. I can now see the total efficiency, radiation efficiency, the mismatch in your antenna efficiency, both in the dB and percentages. And you can also look at the gamma of your measurement on the screen. Yeah, so this is a quick introduction on how to perform a reciprocal antenna efficiency measurement using the wireless connector. It's easy to set up. You only need to calibrate the VNA and then you can continue with your measurement.